Hi everyone. My presentation is about a project that was launched at ARM to add support for a new type of component in OPT, and that is the Secure Partition. My name is Miklós Bálint. I work at ARM's OSS open source software group, and Previously I was working on the Trusted Firmware for M project, and about a year or so I started meddling with the A profile, especially looking at how the platform security, root of trust, service standardization initiatives that were started for the M profile could be expanded to include a similar reference implementation for the rich IoT and infrastructure edge devices based on the A profile cores. So let me just see if my clicker works. No, it does not. Just hang on there. Yep, that's better. So sorry about that. So after an initial incubation period, full-fledged project was started, and the team was formed around this subject roughly in the spring of this year. And the project goals were stated as providing out-of-the-box security for rich IoT and infrastructure edge devices, and provide a reference platform security implementation for Cortex-A devices, including a set of standard platform root of trust services that would be required or that would support enabling devices to be PSA certified. And the whole implementation would be based on ARM's firmware framework for Armv8 or FFA in short. Just a quick recap on the platform security offering that provides the background for this project. So it's a 4-step process, the last step of which is an independent security assessment to provide the PSA certification. Our project focuses on the preceding step of having a open source reference implementation for some of the key security related components in such a device to enable certification at a later stage. I think the background for today's A profile architecture is well understood, and some of the drawbacks that the platform security initiatives are trying to address. Multiple vendors are present at all exception levels, and there are dependencies between various software components, normal world clients and their secure world service providers, and various protocol layers that are specific to the trusted execution environments. The way an important aim in addressing these problems is to provide a standardized trusted firmware running at the higher exception levels, and to have platform and secure services executing at the lowest possible exception levels with the least amount of privilege necessary for them to function, and for them to run in isolated contexts where they are shielded from one another. ARM's firmware framework describes a software architecture that aims at resolving these issues or aims at providing the means for solving these issues. It introduces a few terms that I will be using throughout the presentation. So the isolated contexts where services are executed are called partitions, which are virtual machines in the normal world, and secure partitions in the secure world. The attribute for one of these partitions is described as a partition manifest, and both in the normal world and in the secure world, there's one partition manager each for managing these partitions. In the normal world, that would be the hypervisor, and in the secure world, it's a component that's called the Secure Partition Manager. The firmware framework provides standard interfaces between all of these components and standardizes transport primitives for their interaction. It also provides multiple configurations to cater for the needs of different hardware platforms, and of course the important configurations for the market segments that our project is aiming for, the rich IoT and infrastructure edge devices, are the ones where secure hypervisor layer is not present or is not used. So what does the software architecture look like in that kind of a configuration in the specification? So in that case, the secure partitions are Secure-EL0 or user mode components, and the SPM component is split between a Secure Partition Manager dispatcher component, which relays messages between the normal world and the trusted world, that is implemented as part of the EL3 firmware, and the Secure Partition Manager core component that manages secure partitions and which is implemented at Secure-EL1. So as the first step when launching the project was for us to create a proof of concept addressing the basic concepts in the firmware framework specification. And the baseline for that proof of concept work is OPTE's 3.10.0 release, which already contains an SPMC, Secure-EL1 SPMC configuration. In this configuration, the OPTE functionality itself is unchanged. What's changed is the SMC transport layer, so the transport layer between the normal world and the secure world, and therefore the component at Secure-EL3 which is required to relay the messages. So the OPTE dispatcher component at Secure-EL3, which was there previously, could be replaced by this standard component, the SPM dispatcher component, with this configuration. OPTE functionality is implemented as a single logical secure partition running at the privileged Secure-EL1 layer, and of course in the baseline there's no support for additional Secure-EL0 isolated partitions, which is why our team needed to start the proof of concept to work. The proof of concept that we started is using the V8A architecture model as the development platform. And so what does it include? The proof of concept includes a minimal SPMC based on the specification, which manages multiple secure partitions. To enable that, it implements the virtual FFA ABI at the SVC conduit layer, and to maintain compatibility and interoperability with OPTE's other components, it keeps the implementation defined interface towards the privileged secure partition running OPTE's standard functionality. When choosing the initial design for secure partitions, we took the example of that of early TAs. we created a library to build secure partitions against that would enable us to use FFA ABI functionality from the partitions. We call that the libsp, which from a functional perspective is similar to how TAs are built against libUTE. And an important aspect in basing our design on that of early TAs is the fact that those are deployed as part of the OPT binary and started as within the OPT initialization flow. And since secure partitions are static entities, they are not created or destroyed during runtime, not at least in this version of the specification, the 1.0 version of the specification. So that will seem to be a good fit for our project. To demonstrate all this functionality, we created a minimal set of cryptographic operations in a Secure EL0 Secure Partition and for test purposes. The initial patches for this proof of concept work were hosted, are hosted on trustedfirmware.org Gerrit, and they were made public and announced on the OPT public mailing list at the end of July. The ongoing work since that, so for the third quarter and early next quarter timeframe, we're making strides on multiple work streams. We're implementing an additional standard secure partition, the internal trusted storage secure partition, which includes a placeholder for a hardware driver. It's only a placeholder at this moment because, of course, a storage backend hardware driver is highly platform specific, and we haven't addressed the intricacies of that. Another work stream is that we're focusing on decoupling the partition source and the build flow from that of OPT. This is to highlight that secure partitions are meant to be standalone components and highly portable between various implementations of the SPMC. So because there should be no dependency other than the one specified in the FFA specification. We're also cleaning up the SPMC code and starting to provide documentation, test suites, and a CI infrastructure. So we're trying to do overall improvements to the whole developer experience. The next steps, which is roughly the Q4 timeframe for the project, we are planning a consolidation. So we will make an effort to upstream the SPMC changes to the OPT master repository. Also, we will be working on a normal world application to demonstrate the usage and the usability of the platform root of trust services we have implemented by that time. So to demonstrate that they are ready to fulfill PSA level 1 certification, hopefully. At the same time, we will be launching several investigations, one into the attestation service, which is clearly an important part of a secure device lifecycle, and also into hardware management and interrupt handling aspects of the FFA specification, which are prerequisites to having hardware backends, platform root of trust hardware components mapped to dedicated platform secure partitions, to have them access controlled from a single secure partition each, and So other partitions in the system would only ever get access to that hardware resource by calling a service from that dedicated secure partition. As for future directions and opportunities that we see for this project, there's a plethora of activities that are still to be done or can be done, and we're planning to address those, but it all depends on the interest and the bandwidth that we have. One very important aspect is the packaging, delivery, authentication of secure partitions. As I mentioned, currently they are bundled together with the Opti binary. If we want to eliminate that dependency, we have to look at the implications of that. So an investigation needs to be launched into what the ramifications are for the boot flow, authentication flow, all of that. Another important area to explore is 32-bit support. So support for 32-bit secure partitions and service protocols based on 32-bit partition code. And of course, for a 32-bit only platform, to have an implementation of the SPM core component in supervisor mode, so built for 32-bit. From a security point of view, it's very important to focus on reduced privileged footprint in the system. So one possible course of action is to look at how existing TE functionality can be mapped to root of trust secure partitions, so that some parts of the Opti kernel can optionally be mapped to Secure-EL0 execution, which would help us reduce the attack service at privileged exception levels. Some ways in which we can focus on the portability of secure partitions. So as I mentioned, the secure partitions themselves are independent of the underlying software architecture. As long as a Secure Partition Manager core component implements the virtual FFA ABI at the SVC layer, and it can parse the partition dependencies and the manifest of the partition, it can be executed on that particular setup. And so some options to explore there are Secure-EL0 global platforms adaptation layer, so that TAs can actually be wrapped into secure partitions, to have the standalone MM functionality ported to our SPM implementation. There's already an activity that prepares us for that. So I will there's a dedicated talk for that later, so I will just briefly mention that since as part of that activity, standalone MM functionality is implemented with the virtual FFA ABI as its protocol layer with other functionality in the system, it should be relatively easy to port that into to integrate that into our solution. Of course, another important aspect is that of future or later architectures, newer architectures, which do implement the Secure-EL2 layer, so the virtualization extension, secure virtualization extension. Even in those cases, the secure partitions that we're developing, the platform security components that we're developing as part of this project can be reused, and the framework that we're creating can be reused by adding a shim layer at Secure-EL1 which acts as a trampoline between the partition code and the SPMC, which in this case is executing at Secure-EL2. There's also a dedicated talk on the secure virtualization, so it will be explored in more detail on that. To summarize, we're looking at creating software architecture agnostic root of trust partitions, a reference implementation catering for the requirements that we understand the rich IoT and infrastructure edge devices may have, with a focus on the PSA certified program. If you want to get a bigger picture view of how this fits into the wider trusted firmware project, just stay tuned for the next talk. If you want to provide feedback, we're on the Opti mailing list, and so feel free to reach out. And for the active reviews, I just attached a link in the presentation. And I don't know if we have the time for some questions we should have.
Yes, Miklos, this is Derek Miller with ARM Research. Nice to talk to you again.
Yeah, hi.
One question that we had when writing the internal trusted storage APIs and requirements was what does internal trusted storage look like on the A class? You mentioned the driver earlier. Do you have a better answer for that now, or any answer? I mean, I don't, you know, I never knew what the answer was, so I'm curious.
So what exactly the storage backend for a particular A profile device is? No, I don't think I have the appropriate answer at this point, because we have yet to find the first platform, first physical hardware devices to port this on. We're, as I mentioned, working on the architecture model. We do have some ideas from some partners on what that might look like, but I don't think that we're at a stage where we can have a meaningful conversation about that.
Okay, thanks.
But certainly, so currently our implementation is a RAM-based file system. Mm-hmm. But we're trying to have a hardware abstraction there, and so any partner can fill in the appropriate backend as needed.
Okay, thank you.
Sure. So any other questions? I don't see questions on the chat nor on Slack.
People raise their hand. I just allowed them to talk. So,
hi, this is Varun. So I had one question. This is related to the previous question about the storage. So, I mean, RPMB is one storage, right? So maybe I did not get the question, maybe, but the secure storage, right? So RPMB is one of the solutions that is being used. What other storage models are being explored? I would like to understand.
So at this point, we're creating the hardware independent platform code. So we're at this point, it's not in scope for us to look at the various backend options.
Okay. Yeah, but just one clarification that RPMB is one of the backends that is already being used, right? The RPMB solution with the MMC. So that is, I mean, that is one option that we have.
Yeah.
And I mean, what other, okay, so fine. So I just wanted to clarify that. Thank you.
Yeah, essentially any storage backend that fulfills the requirements and that some of the partners find feasible should fit the bill. I don't know if they have a dedicated store or something like that. I think we're out of time.